Great. So welcome everyone to the Data Science Autograding webinar. We've already done webinars on Java and Python, and today we are going to cover how to set up data science assignments in CodeGrade. The reason why we do this webinar now is since we have recently, of course, released the AutoTest caching. And with the AutoTest caching, it just becomes a little bit easier to assess data science automatically, since with data science you're often working with big data sets and data files. You have to install large libraries maybe, and that's all now possible while still giving instant feedback because of the caching. So that was a really good reason to do this webinar now and to give a basic introduction to data science in CodeGrade. So what I want to cover today, first is some general ideas about data science. So why we think instant feedback is important for data science students. Then going over how to set up your auto test in a way that you can also use hidden data sets and cases. Finally, talking a little bit about uploading or downloading your data sets. And finally, explaining how you can use AutoTest caching to make it all work really well. After that, I'll go into setting up a basic Python data science assignment in CodeGrade and setting up a basic R data science assignment in CodeGrade. Especially the Python one, I won't go into too much detail since we've already covered a lot of Python autograding in the previous webinar, which you can still watch on demand on our YouTube channel. And a data science assignment simply doesn't add that much to what we've already covered. For R, we will be going over some simple R assignments in CodeGrade that will hopefully give you enough idea on how you can set up your own data science assignments. Again, I'm trying to keep this really basic because there's a wide variety of different things you can do with data science, and there's a lot of different methods that teachers use. So I want to keep this basic so you can use this information to set up your own assignments. So let's start with why we think that instant feedback is important, especially for data science. And we think that that is the case because data science is a very popular discipline nowadays amongst non-computer science students as well. Especially if they're majoring in data science or they're doing a master's in data science, their first experience with programming is mostly during that course. And instant feedback helps motivate these students and accelerate their learning, especially if they don't have any prior programming knowledge. And also with autograding, it is really easy for you to set up many basic programming assignments or exercises that are fully autograded so that you don't need any manual grading, but the students have a lot of material to get a head start. Also, data science assignments are often compiled of many different tasks. You have one data set and you have to maybe compile different parts of data from that or put it in a specific table. And with CodeGrade, it's really easy to grade each of these tasks automatically and individually. And because students can upload as many times as they want, it is a really motivating way for them to make visible progress throughout the assignment, since every time they upload, they can see that they tick another box and another one of their subtasks pass. So these are just some reasons why we think data science is important. Some other things just generally that you can do in CodeGrade that will help out with your data science assignments. So first of all, oftentimes when you have a data science assignment, you'll be providing your students with a data set. They can download that or you will provide that to them. But of course, you want their code to also work with a different data set, or you want it to work with different test cases. What you can do in CodeGrade AutoTest, and you can see that in the image right here, is you can differentiate between some tests that will run every time a student uploads and are visible to the student, and tests that are hidden to the student. And as you can see right here, the bottom two tests are hidden to the students, this one and this one. And these will use an extra data set that you've hidden and uploaded as the picture. In this way, the students can get feedback before the deadline, but then you can also confirm that their assignment works on a more general level automatically after the deadline, as these tests that are hidden will run automatically after the deadline has passed. You can set these up really quickly by just pressing the eye icon behind one of these tests, and that will make the test hidden. Now, of course, with a data science assignment, you will probably need to have a data set. Most data sets, luckily, are below 50 megabytes, and you'll be able to simply upload them as a fixture in CodeGrade. And we've covered this before, but you can go to the AutoTest tab, you can upload the fixture and then press submit, and then it will be available in the fixtures folder. Something that is important to note here, if a student uploads a file inside CodeGrade, if that's an archive, it will be automatically extracted. But for these fixtures, we do not automatically extract them. So if you upload an archive or a zip folder, you will need to extract it manually if you want it to be extracted. And you can do that by a simple command like unzip, and then you specify which file you uploaded. In this case, it's in the fixtures folder, and it's called specdata.zip, and then you extract it in the current directory. And this line of code can be used in the per student setup script and can be used in that way to set up the environment for the student. Now, if your data set is more than 50 MB, or if you want it to be a dynamic data set that you maybe change throughout the assignment, you can also choose to download it. And downloading is really easy, and you just simply can use the wget command that you probably already used in Ubuntu as well. And by just specifying where you want to download it, and with the O flag right here, we specify that we want to rename the file to this directory as well. And then afterwards, we specify where we download it. And by doing this in the global setup script, we'll download the file once if we're using AutoTest caching, and the file will be available, in this case, in this path. So these are just two ways to get your data files inside CodeGrade. Now, finally, and the whole reason why we are doing this webinar right now is that we introduced AutoTest caching. And if you go to your AutoTest page, you will see that in the Setup tab, you will have a new option, fourth option, which is called Setup Caching. And you can enable it and disable it. By default, it's enabled. And what this means is that every time you set up, or every time the AutoTest gets a new submission from a student, it will not redo the whole setup, but it will just use a cached version of that. And in that way, even if you install a lot of scripts, the setup will be near instant. This has, of course, the advantage that the student will get a faster feedback from AutoTest, but also that while you are testing your AutoTest, you have a quicker testing cycle, since all the tests that you're changing will not alter the global setup script, and you can just use the cached configuration every time. So those are two benefits. Of course, you may not always want to use this. Of course, for most assignments, it's very useful, especially if you install new software or packages, which takes some time, or if you download or upload a large data set, or if you are testing your AutoTest and you don't make any changes to the setup, it's definitely useful to use caching so that you don't have to wait for the setup every time. But there are some reasons why you may want to disable it. And that is if you always need to use the latest version of the software you install. Of course, if you have the configuration cached and you install, let's say, a Python package, and your assignment is up for a week or two, and the Python package gets updated during that time, you will not have the latest Python package in your AutoTest. Instead, you'll be using the old version that is cached. So if you require the latest version of all software to be used, then you should disable it. Also, the same goes for the data set. If you download the data set and it's dynamic, you may want to disable caching so that every time a student uploads something, they will have the latest data set again. Finally, if your configuration in some way depends on live data, like a time, date, or generates a random number or something like that, you may also want to disable it, since then it won't work anymore. So these are just some notes. And one final thing to remember is that already before we added this version, if students hand in very closely to each other, there will already be some caching being done. So students will share the same virtual machine, and they may not always have the latest version of software already. But that has always been the case, and that's not dependent on the AutoTest caching step. All right, so these were just some general thoughts, and I see there is a question. Is that something you want to discuss, Lina?
Yeah, so there's a question in the chat, but you could still download latest from student setup scripts.
Yes, so the per student setup script, that's a really good question, is done every time a student submits. So that will not be cached. So only the global setup script will be cached, and everything you do in the per student setup script will always be run every time a student uploads. So that will be done live for every student. Great question. So now that we've covered some general thoughts on data science and CodeGrade, let me go over some quick tips on how to do that for a Python assignment. And since we've already done many webinars and tutorials on Python assignments, I will not cover this in too much detail, but just go over it really generally. So first of all, of course, we pre-install many things by default. For instance, NumPy and SciPy are installed by default. But often, if you're doing a data science assignment in Python, you will probably need some other packages as well. You can really easily install new Python packages by using the pip3 command, which is installed by default, and you can use the global setup script for that, so that it's cached. And in this case, we're installing Tensorflow and pandas, two very common packages for data science assignments. But of course, you can use any package here. So that is best done in the global setup script, and you can simply use the pip3 command. And you can just use the pip3 documentation as well if you want to do special things with this. Everything that works for pip works in CodeGrade as well. So now, to autograde a Python data science assignment, it's the same as a normal Python assignment. You can do that in interactive mode. So you can open a Python script that a student has uploaded. You can use the -i command or flag when running it, and then it opens in interactive mode, and you can test specific functions. So in this case, we open a airline safety analysis.py here. And as input, since it's interactive mode, so we can give standard input, and that standard input can be simply Python code. We run the most fatalities function, and then the expected output is this list or data. And that is a really easy way to autograde Python code. Of course, if a Python code or if a student doesn't use specific functions, or if you do not force them to do that, you can also just grade a whole Python file as a whole in the same way as this, but then without the -i flag. Also for data science, of course, oftentimes you'll use a Jupyter Notebook. There's a couple of things you can do with Jupyter Notebooks. We've already covered this before, but let me really quickly say it again. So of course you can run a Jupyter Notebook automatically. You can convert it like with this command to put it in the AT output folder. And this is a folder where you can put files or data in that will be visible in the code viewer. So after this has run, you can go to the code viewer and you can see the AutoTest output part of the file tree. You can click on the IPython notebook and you can visually inspect the output of the Jupyter Notebook that has just been freshly run. So for instance, if a student has to make a plot or a table, you can do it like this. But of course, you can also autograde your Jupyter Notebooks very simply with input-output tests. And that is done by 3 steps. First, we have to convert the Jupyter Notebook to a regular Python script. And what that does, it simply extracts all the code segments of the Jupyter Notebook and appends them to one Python script. Afterwards, you can just very easily import that Python script again, just like we said before, in the Python interpreter, or if you know exactly what you want, you can run it. And in your AutoTest, you can simply give standard input and then check variables like we do right here, or you can run a function again, like we've done before as well. And this is just really easy stuff. So first of all, we convert it to a IPython notebook, and we do that in the run program step. We convert it to a script, and that script will be called Amazon bestsellers.py. Then afterwards, we can use the Python interpreter to import that script. So in this case, we give the command to import that script right away. So we say Python 3, interpreter and the command, and then we import the script that we just generated. Then this is what we see in total. So first we run program step, generates the file, we import it here. And then as we import it, we can, as standard input, just give regular Python code, in this case, call a function, and then check the output for the expected output. Very easy. Again, if you would like some more information about this, we have a 45-minute Python autograding webinar where we go into more detail for Python autograding. So in that case, definitely check that out. All right, so we will now go over some basic R data science. Of course, R is one of the most used languages for data science, and we've not covered that in a webinar before. We do, however, have a blog post about our assignments and our autograding. So if you are interested in the specific scripts that I use, or if you would like to read it through, you can find that on our website. And it basically says the same as what I'm about to say. So first of all, let's go over installing our libraries. And in general, there's two ways to do that. Either we can allow the students to directly install libraries themselves, or we can install the libraries beforehand by as a teacher in the global setup script. So of course, the method where we allow the students to do it themselves has the benefit that we can allow the students to install everything. However, you have to take into account that installing an R package or an R library is very time consuming, and this may very well slow down your AutoTest. If you are doing it beforehand, of course, you have to guess which packages your students use, or you have to enforce that they only use certain packages. I'll show you both of these ways. And first of all, what we have to do is we need a script to set up our user library. And because this is not set up by default in CodeGrade. And we need these two lines of R code. We can save them as setup.r. So first of all, we set up we get the user library environment variable, and then we have to create that user library. And that is basically what these two lines do. We can save that as setup.r, and we can run it in our global setup script to configure the whole environment so that we have this user library and we can install packages there. And again, you can use the R script fixtures setup.r command in the global setup script. These two lines of code can also be downloaded from the blog post. Now, after we've done this, basically the environment is configured so that students can install packages, or you. And if we allow the students to install packages themselves, we have to take into account that it can take a little bit longer. So we need to increase the timeout per step, which by default is not that high. I think from the top of my head, 120 seconds is the default. Since installing a package can take a little bit longer, try this out yourself and make sure that the code or the step does not time out if a student wants to install something. Another thing that is important is that we enable network access, since the students have to download the package, of course. So in this way, we can allow students to do it. Of course, we can also do it ourselves, and that is very easy. All we have to do is add one line to the script that we already had. And that is just the install packages line. And we specify in which library we do that. And here is the package name. So in this case, we install tidyr, but of course you can replace this with anything else. Again, this can be done in the global setup script, and this can take a little bit of time. But with the AutoTest caching turned on, you can, of course, only do this installation step once, and then every subsequent submission will use the cached installed libraries. Of course, you can also combine these two by guessing some libraries that most students will use, but still giving the students the option to install their own packages. In that case, you can use this script, install your own packages, and make sure that all the steps where you run student R code, that network is disabled or enabled, and that the timeout is high enough for it to not time out if a student downloads their own package. So those are two things to note. So for creating automatic tests, there's also two ways to do that in R. The first one is autograding an entire R script, which is the most easy. In this case, we have a simple Fibonacci.R script, and we can use the R script command to run this, and we can check it for expected output. So in this case, the expected output is right here. And this just checks the whole script with a whole input and a whole output, or in this case, just the output, as we specified to the student how many digits they have to output. Another thing we can do is autograde specific R functions. And that can be done using R script again. But in this case, what we add is the -e flag. So we can give R commands. In this case, we start by sourcing the Fibonacci.R file, and then we end again with the E flag. And the reason why we end with the E flag here as well, this is not a typo, is so that we can append another command after this. And this command will be the function that we want to execute. And in this case, we run Fibonacci, but this time with only 5 digits, and the expected output is here. So what we do is we append this Fibonacci 5 command. After this, that will be the full command, and this is the expected output. The reason why we add this vanilla here, and I think it is not totally required, depending on the R version that you use. But just in case, with the vanilla flag, what you do is you make sure that every time you run R, you have a fresh environment and nothing is saved, and there's no leftovers from previous runs from the same category that you may have. So depending on the R version, you may want to add the vanilla flag here as well. So these are the two ways that you can set up your R script. And I think we do have enough time to set up a small R assignment. So let me change my tab here. And I have a fresh CodeGrade assignment here. And what I want to do is I want to have a air pollution assignment. So what I have is a data set, which is called spec data. We've discussed it before. And it has data from different measurements points in the US on air pollution. And with our Python script, or with our R script, we want to do some data assignments on that. So let's first copy a rubric. And in this case, we want to copy it from our previous assignment. There we go. Import it. So now we have a rubric set up, and we can start to create our auto test. First of all, let's make sure that setup caching is enabled. So we see that option here. And let's upload our 2 fixtures that we need. So for this specific one, we need our spec data fixtures, of course, and we want to install our requirements as well. Let me just quickly get that one as well. All right, so we have the data file that we want to use for this assignment and our install requirement script. And that is the script that I've talked about previously. So when we uploaded this, we click on it, we can see that it sets up the user library and it installs the tidyr package. The script has to be run, of course, and we do that in the global setup script. So let's run it with our script and then say pictures. Since we uploaded this picture and it's called install requirements.r. So now we execute the script in a global setup script. We install the package, and then in the per student setup script, let's unzip the spec data file, and we do that like this. Zip. So we have our spec data set up, we installed the requirements, and we can now create some tests. And for our first assignment, let's set up some IO tests here. And let's start with task 1. And again, here we want to try out some functions that the student has added in. So we'll use the vanilla flag, E, and then we source the assignment that they upload. In this case, it's simply called assignment1.r. And again, with the E flag, so that we can give the input argument that we want. So let's now check for sulfate, and from measurement point 1 to measurement point 10. And we can do that by running the assignment1 function that we've created, and then giving some arguments, which is spec data, sulfate 1 to 10. And so in this way, all we're doing is we are running the assignment1 function with these arguments in the assignment1.r file. And we are expecting a certain output. And in this case, what I will do is I'll turn off substring match. Normally, I always recommend to turn it on. But in this case, of course, if the student adds more data after this, or they have some more decimal points after this, we do not want this to be a valid response. So for most data science assignments, I think substring match should be left turned off. So let me add one more option here, one more input output. So now we want a nitrate check. And again, we will run the assignment1 function. Again, load the spec data and give the nitrate option. And since we want to check all the data points, in this case, we do not add a range like we did here. So now the output that we expect is this. Oh, that's not the output that we expect. This, and again, substring match is turned off. So these are two ways, or these are two input and output tests with the specific function checking. So let me add a new category now for the assignment 2 that we've defined for our students. And in this assignment, we specify to the students that they simply have to list the first 100 data files. We just want that to be the output of the whole assignment. So in this case, what we do is we add a new IO test again. We call it task 2. And we say program to test is our script assignment2.r. And let's give this input up per name, list first 100 data points. And we expect this output. So this is just very long output with all the data points. And again, we want to disable substring since we don't want them to add more data points after this point. And as you can see right here, we will leave empty all the input and or input arguments and input, standard input here. And that's totally fine. We don't need to have input since in this case, all we are checking is the output. So you can use an input-output test also as a simple output test by just leaving the input empty. So let me save this. And now we've set up our two categories, and I can start our auto test. And let's try it out by handing in a file here as our submission. Right, so I'm uploading assignment 1 and assignment 2, submit it as a test submission, of course, and it will show up here. And now we'll start the VM, configure it for the first time, which may take a little bit longer. But it will also cache it automatically so that the next time we start it up, it will be near instant. And I can show you that a little bit later on as well. So while we are waiting for this to start, let me simply go to the next slide here. And that is about custom descriptions. In this assignment that we've set up, we are using the R script with the vanilla flag and the E options. And for a student, that of course is a little bit confusing. They do not know exactly what you are testing there, and they don't have to know exactly which flags you're using and things like that. So for that, what you can use is custom descriptions. And I highly recommend this for every assignment, but especially for assignments like this, where your commands that you are using are a little bit vague and hard to understand for students. So what you can do is you can open advanced options. And for input-output tests, you have 2 different description templates that you can create. One is for the whole test, and the other one is for all the individual sub-steps, so the individual input and output pairs that you've set up. So in this case, what I've done is the whole test I've called check assignment1.r for correctness, and assignment1.r will be in code, since I'm using the backticks around it. And then for the sub-steps, I am using the name of the sub-steps. So what I just used, like the sulfate and the nitrate, and I'm making the name bold, and I'm doing that with the stars. This will result to the student. It will show up as this. And of course, this is way easier for a student to understand than what we're seeing right here with the whole command and everything. So as you can see, timing is perfect. It just started running, and it passes all the tests. And as you can see right here, the input and the output is exactly the same. So just to show you how you can set up these custom descriptions, and hopefully also demonstrate these AutoTest caching. Right here, if we open our category, we can scroll down to advanced options, and we get the description templates. So let's simply add something. And then right here, we can toggle it. You can see that Markdown works. And then right here, checking again. And the available substitutions that you have are available down here. So in this case, we have the command and the name. And for sub-steps, with the command prefix, command suffix, and the name. And the command prefix, of course, is this part that we have right here. And the suffix is the one that we are appending to it. So let me save this. And now we can see it changes. And hopefully if we press start now again, and this is the beauty of the AutoTest caching, we have this whole setup script for this assignment, but we just changed a little bit of our testing steps. And instead of building a new VM, it is now restoring our previous VM, and it is already running tests right now. So also for you as a teacher, iterating your tests becomes way quicker and way easier and way nicer to do than having to wait for the whole setup script to run every time. I've done it a lot of times, and sometimes it's a real pain. So it already finishes, and we have the updated custom descriptions now. Awesome. So let me get back to the tests here, to the slides, because that was it. Of course, if you want more help with your data science assignments, we're always here to help you out, give you consultations for that. Of course, what I showed you was just a really basic R assignment. I covered some Python as well. In the previous webinar, there's way more Python stuff. But I hope this is giving you some inspiration to set up your own data science assignments. So I'll now stop recording so you have some time to ask your questions.